Hello, and welcome to the Green Chemistry of Solar Energy presentation by Zanab Ashraf, Finn Donovan, and Pablo Lemus. My name is Finn Donovan, and thank you for joining us. What is solar energy? Solar energy is the renewable energy we can collect from the sun and is the most abundant form of energy on Earth. Energy packets known as photons are irradiated by the sun towards Earth, which can be redirected into other useful forms of energy. Solar energy can be converted into electricity by either photovoltaic cells, which use light, or thermogalvanic cells, which take advantage of heat. Photons must travel 93 million miles to get to Earth, yet only need 8.5 minutes to complete that journey. Now, the history of thermal solar energy. In 1973, Dr. Yanis Sakas demonstrated that Archimedes actually could have burnt down the Roman navy in 213 BC by using reflective mirrors focused on singular places of ships to generate a large amount of thermal energy needed to catch the timbers alight. In 1767, Horace de Saussure created the first solar collector to trap thermal energy within a small glass box. The first thermogalvanic cell was patented in 1957 by Hermann Lipavsky. The history of photovoltaic energy. The first photovoltaic array was developed by Charles Fritts in New York in 1884 using selenium cells. The energy conversion of this array was a mere 1%. However, the first solar panel using silicon cells instead was developed by Bell Labs in 1954 with an initial 4% energy conversion efficiency, which within 6 years would reach 14% in 1960. Today, the most efficient concentrated photovoltaic cells can achieve up to 41% efficiency. Now, where does our energy currently come from? Now, from this graph, you can see that in 2018, the number one place that energy was produced for households in the U.S. was done by natural gas, followed by coal, nuclear, and renewables in that order. Also from this graph, you can see that the trend lines of natural gas and renewables are the two that are positively increasing their market shares and increasing their output of energy, while coal and nuclear are both decreasing, coal far more seriously than nuclear.
Potential of solar energy. Although about 20% of the solar radiation reaches the Earth, this amount of radiation could harness 173,000 terawatts of energy. Solar thermal systems covering 10% of the world's deserts could generate about 15 terawatts of energy. Solar energy use is increasing within China, Japan, and the US, leading in installed solar capacity. Solar energy for electricity. Why solar energy is a valuable renewable energy source. Just 40 minutes of sunlight striking the land surface of the US can yield the equivalent of energy of 1 year's expenditure of fossil fuel use. Solar energy can be used to provide electricity through photovoltaic cells. Photovoltaic or PV cells contain thin layers of semiconductor material. The kinetic energy light photons strike the layers, which create a current. PV cells are primarily made from silicon, which is one of the most abundant elements on Earth. Solar energy for heating. Solar power can be harnessed to heat water and spaces. Water can be heated through flat plate collectors that absorb and trap heat from sunlight. In China, 10% of households' hot water comes from solar thermal systems. Solar heating can also be applied to buildings by insulation techniques and installing windows that face the sun. Solar heating systems reduce the economic and environmental costs that stem from using fossil fuels. Drawbacks of solar energy for electricity. This is still more expensive than conventional energy sources. It only works during the day, so an energy backup or storage equipment is required. This requires a sunny climate. Drawbacks of solar energy for heating. The installation is expensive. Hot water cannot be stored for long and needs a backup source. Efficiency is climate dependent. These drawbacks should be compared to the drawbacks from traditional energy sources like greenhouse gas emissions, waste disposal, and pollution.
And furthermore, into solar panels, we have different types of solar panels if you are looking into buying them. Two of the most popular ones are monocrystalline and polycrystalline. Their efficiency rates are different, and also the price points. So monocrystallines are going to be a little bit more on the higher end, very expensive, and just high quality because they're made out of single crystal silicons. So very, very fine detail. And polycrystalline, on the other hand, are going to be a little bit cheaper with a lower efficiency rate, like I said, but they're made up of fractured fragments of silicon, and they're just put together. On the other hand as well, we have thin film, which is another one. They're made out of amorphous silicon solar panel, they're amorphous silicon, and that's the composition of into the solar panels. We also have concentrated PV cells with a much higher efficiency rate, but also on the higher end of the cost. And speaking about costs, if you plan on installing solar panels, now is the time to do it because you have a federal tax credit. And if you look at the chart here, it shows you what the tax credit's looking like for the next few years. So let's say, for example, if you are planning to install your solar panels, you go out and you buy them. Installing is also going to cost some labor because I'm pretty sure you're not going to do that by yourself. Unless you do, I don't know. But let's say you spend about $30,000 on your project. And the federal tax credit, what it does, or the federal investment tax credit, what it does is that it'll give you a 30% reduction on the cost. So instead of $30,000 last year, it would have just been $9,000 less. This year, it's going to be a 26%. So they reduced it down to 26%. So you would get a $7,800 tax break. And then for next year, it's going to be even lower to 22%, and then lower for 2022 to 10%, bringing it down to about $3,000 in your tax credit reduction. So if anything, the big takeaway from this is that if you do ever want to be modern and you want to buy solar panels to look cool, now is the time to do it in 2020 before the federal investment tax credit goes down. And you have to own them and you can't rent them. That's the big thing. So getting in your Form 5965 before those tax credits go down. Here we have an emissions by energy source chart. This was taken from the U.S. Energy Information Administration. So on the left side, we have the energy consumption by major fuel type, just showing the four major ones, well, three of them actually. So we have natural gas, petroleum, and coal, all fossil fuels. And then on the right side, we have the energy-related carbon dioxide emissions by major fuel type. So basically, the amount of CO2 produced depends on carbon and hydrogen content. So natural gas is mostly made of CH4, produces less CO2 for the same amount of heat produced, saying that natural gas is a better option if we ever do go that route instead of solar. But our goal here is that we want to eliminate all these carbon footprints. So solar energy would just not be on this chart at all because it doesn't produce any carbon dioxide, right? But the energy consumption would be a lot higher if we can get those efficiency rates higher. Moving on, we are going to talk about the life cycle emissions from electricity generated. Here, as you can see, that coal is at the highest because it produces the most carbon dioxide. You have a lot of carbon molecules in coal and less hydrogen molecules, so that's going to produce a big carbon footprint on our planet. As you can see, it's up there, very up there, above gas, above biomass. And as you can see, so domestic solar photovoltaic cells are at 41. That's a very huge decrease in cycle emissions. So, like I said, solar panels are the way to go. In regards to the future, we are trying to reduce coal energy production. So, the way that we're kind of compensating for that from this chart, as we can see, is that we've been finding new ways of using renewable energy sources. Natural gas is not a renewable energy source, but it is coming up and kind of taking over the coal industry. But solar panels, they are very small. They don't really have industrial size, like very large ones. They have to be in packets when you buy them. So when you go on on a website, you'll find like packets of 4, an installation kit or whatever. They're small, but if we have enough in every house, they would be able to power basically an entire city by itself. So there is a market for that now, where other renewables like wind or hydro cannot tap into. So we're individualizing the energy consumption there. Another cool thing here is that we are looking at new innovations for solar energy, the technology. So like I said, whenever you think of solar panels, we think of them as either being on farms, out in the open, or on top of houses, right? Because that's where you're going to get the most of the sunlight. Another cool way is that you can take these solar panels and just put them on this very volatile sheet or a versatile sheet, so it can move around and be versatile and capture more of the sunlight in oceans or reservoirs or small lakes, whatever, dams. And the great takeaway from this as well is that that your energy production will actually increase by 10% due to the cooling effect of water. So lots of cool innovations being made here and lots of new innovations coming in the future. Hopefully those efficiency values increase as well. And the only way to do that is by increasing awareness of solar energy panels and the technology behind it, so that we can move forward and create a better, brighter future. So that is our presentation, and thank you for listening.